Hello everyone. So this is our part 2 of our video series in which we will try to solve the exercise questions based on the chapter binomial distribution. Now starting again exercise 1, question number 5. If hens of a certain breed lay eggs on 5 days a week on an average. Here they are talking about a certain breed of hens, and these certain breed hens lay eggs 5 days on a week on an average basis. Find how many days during a session of 100 days. Now we have to find how many days during a session of 100 days a poultry keeps with 5 hens of this breed. They are talking about a particular poultry, and this poultry has 5 hens of this particular breed which lay eggs 5 days on an average in a week, receive at least 4 eggs. What is the probability of receiving at least 4 eggs when this poultry keeps 5 hens of this particular breed, and this particular breed hens lay eggs 5 days on an average basis in a week? So from this information it is very clear that we have total 5 hens of this particular breed. So here n, number of items or number of trials or number of observations, they will become 5. Then this particular breed hens lay eggs 5 days on a week on an average basis. So the probability of laying eggs is equals to 5 by 7, because a week contains 7 days, and out of these 7 days these hens lay eggs 5 days on an average, and the probability of failure or probability of not laying eggs will become 2 by 7, as we all know that P plus Q, probability of happening of an event plus probability of non-happening of event, which is denoted by this Q, is equals to 1. So probability of happening of an event means probability of laying of eggs plus probability of non-laying of eggs is equals to 1. N is equals to, here this is capital N. This capital N records the period of the session, which is 100 days given in this question. Now they are asking for the probability of receiving at least 4 eggs. So calculating the probability of at least 4 eggs will be like this. Now we have to calculate the probability of at least 4 eggs, and they are laying eggs 5 days in a week on an average basis. So for at least 4 eggs, the probability will be calculated like this: probability of 4 eggs plus probability of 5 eggs, because we have total 5 hens. Now calculating the probability of 4 eggs, we will use the formula of NCX q की power n minus x into my p की power x, and substituting the values in that formula. 5C4, 5 is n, which is total number of hens. C stands for combination, and this 4, because we are calculating the probability of 4 eggs, into my q की power n minus x, and the value of q is 2 by 7. So substituting the value of q in place of q, 2 by 7, 5 minus 4, which is n minus x, into my p. The value of p is 5 by 7, and the value p की power x, which is 4. So the power of p is 4. 5 by 7 is to power 4. So now solving it, by using the formula of combination theory, which is n factorial upon में r factorial into में n minus r factorial. The value of n is 5 and the value of x is 4. 5 का फैक्टोरियल अपॉन में 4 फैक्टोरियल ब्रैकेट के अंदर 5 माइनस 4 का फैक्टोरियल इनटू में 2/7 की पावर 5 माइनस 4 इट विल रिमेन 1 इनटू में 5/7 and 5/7 is to raise to power 4. Now after calculating the probability of both 4 and 5 eggs, we have to convert the total probability into number of days, because they are asking for the total number of days during a session of 100 days, which we would expect at least 4 eggs by this breed of hens. So this is the total probability of at least having 4 eggs into my number of days in a session, which is 100 days. 0.5578 into my 100, the number of days will become 55.78, and we clearly know this, that number of days, it can never be in fractions, so we have to approximate it. It will become 56 days. So that was it for the question number 5. Now moving to our next question. This is question number 7, and in this question they are saying out of 320 families with 5 children each, we are taking data of 320 families, and out of these 320 families, each family contains, or each family has 5 children. What percentage would be expected to have? Now they are asking for what percentage would be expected to have. And the first point they are asking for 2 boys and 3 girls, and in second point they are asking for at least 1 boy. Assume equal probability for boys and girls, and we have to assume the probability of boy and girl birth rate to be equal. So in this question they are saying that we have total 320 families, and out of these 320 families, each family has 5 children, and we have to tell what percentage would they expect to have at least. Under first point they are asking for at least 2 boys and 3 girls. Out of 5 children, we have to calculate in those families there must be 2 boys and 3 girls, and under second point they are asking for having at least 1 boy. And for calculating the probability of these 2 points, these 2 sub points, we have to assume equal probability of both boy and girl birth rate as equal. So now moving towards the solution of this question. Firstly, we have the data of 320 families. So this 320 to be denoted by the symbol n. So capital N is equals to 320. And these 320 family, each family is having 5 children, so small n will become 5. So capital N is 320, small n is 5. Now moving towards our assumption of probability of success and probability of failure, or you can say probability of happening of an event and probability of non-happening of an event. Now in this we have to take probability of success. We are assuming it as boy birth rate by the probability of success. So probability of success, we are taking it by the birth rate of boy, and we clearly know that the chances of birth of a boy or girl are equally probable. So probability of boy is equals to 1/2, and Q, probability of non-happening of an event or probability of failure of an event, which means, which we have taken in P, complete opposite assumption will be taken in Q. Q will become girl, and the probability of birth of a girl child is also equals to 1/2. So these are the basic assumptions for this question before solving the points that they were asking for. So under first point, they are asking for calculate the probability for 2 boys and 3 girls, and this is clearly a confusion point, because every family, each and every family, they all are having 5 children, and out of these 5 children, it is very obvious when they are asking for the probability of 2 boys, the other 3 children will be girls. So you can write it simply as simply 2 boys, that will also be fine. If you are writing it as 2 boys and 3 girls, that is also fine. But here we are finding, or we are calculating the probability according to boys, because we have assumed the probability of birth of a boy child is equals to half. So here our success rate will become 2. So x is equals to 2, because we have to find the probability of exactly 2 boys out of 5 children. Now, using the formula of binomial distribution, which you all now learn that formula, which you all must remember this. And the formula is ncx q की power x into में q की power n minus x into में p की power x. We have only this formula for calculating the probabilities according to binomial distribution. We are going to use just this formula for each and every probability question under binomial distribution. So now substituting the values into this formula, ncx, in place of n we will write the value 5, and in place of x we will write the value 2. So it will become 5c2, or 5 combination 2, into में q and its power is n minus x. The value of q is 1 by 2, and n minus x, in place of n we will write 5, and in place of x we will write 2. Next, p and its power is x, and the value of p is 1 by 2, and the value of x is 2. After substituting all these value into the formula and calculating the formula, solving the formula, we will get the final probability, which is 10 by 32. But you have already read that they are asking for what percentage would be expected to have. They are not simply asking for probability of having 2 boys and 3 girls. They are asking for percentage which we would expect to have in a family of 5. So calculating the expected percentage by multiplying this probability with 100. 10 by 32 into 100. So percentage is 31.25%. That's it. This was the solution, or this was the answer for first point of question number 7. After completing first point, now moving towards the second point of this question, which is asking for the probability of at least one boy. Now, under second point, they are asking for the probability of at least one boy, or having at least one boy in a family of 5 children each. Now, each family is having 5 children, and out of these 5 children, we have to calculate the probability of at least one boy. At least one means there must be one boy, or 2 boy, or 3 boy, or 4 boy, or maximum there can be 5 boy in a family with 5 children each. So we have to calculate the probability of at least one boy. At least one boy means कम से कम 5 में से 5 बच्चों में से एक लड़का होना जरूरी है. कम से कम one, at least one. And when we talk about at least one, we have to go in the moving, we have to go into the increasing direction. So probability of one boy plus probability of two boy plus probability of three boy plus probability of four boy plus probability of five boy. But calculating the probability of each boy is a time consuming task for us. We can't calculate the probability of 1, 2, 3 or 4 or 5 boys single-handedly. So we have to go for a shortcut. So instead of using this, we can also calculate the probability of at least one boy by subtracting the probability of 0 boy out of 1. Whether you can solve it by the method of using this 1, 2, 3, 4, 5, or you can solve it either by subtracting it from 1. Choice is yours, but always prefer for that method which consumes less time. So we are going with the second way, 1 minus probability of 0 boy. Now calculating the probability of 0 boy, our success rate will become 0. And again using the formula of binomial distribution, which is ncx q की power n minus x into p की power x. Substituting the value in place of n, we have to put the value 5. In place of x, we have to put the value 0. Our p and q is 1 by 2, 1 by 2. In place of n minus x, 5 minus 0. And in place of x, we have to put 0. After substituting all the values in the formula and after solving it, you will get final probability 1 by 32. Now repeating the same thing again, that they are not asking for simple probability, they are asking for percentage. How many percentage, or how much, in how much percentage would you expect to have at least one boy? So we have to calculate the expected percentage by multiplying this final probability with the 100. So 0.96875 into 100, 96.875%. Out of 100%, 96% families are those which are having at least one boy.